Hello, Professor. This is Julia Schneider, and this is my 6th video correction for Survey of Calculus, Math 130. This video correction concerns learning objective A3, which states I can identify intervals of increase and decrease, concavity, local extrema, critical points, and inflection points when given a graph or function. And same type of note. I'm sorry, I just couldn't really process it. No, Liz and I had a note card, so even if I didn't know the quadratic formula, but here it is, and I didn't even need it for this, so that's funny, but, I was kind of all over the place. I kind of had the right idea going. As you can see here, I just don't have 0. I just dropped it as a critical point, which is wrong. And then, this is correct. This, who knows what I was trying to do there. All I had to do was, solve for x, which gives you the point of inflection. But yeah, I was just kind of, let's get into the correct version, but you can see where I was headed with it, at least. And yeah, that's awesome. So basically, to solve it properly, the first part, so A, states, find all critical points of the function g of x and determine which are local minimums and which are maximums. Be sure to explain how you know. So we use the number line sort of technique in this scenario. We did this a bunch in class. And basically, I have to take the first derivative of g of x, which I did correctly on the test, and set that equal to 0, and then take those points and set those equal to 0. So we have critical points at x equals 0 and x equals 13. Since this is the first derivative of the function, that means these points are maximums or minimums. And so we put them on the number line and we test values. I tested -1, which is less than 0, 1, which is in between 0 and 13, and 14, which is greater than 13. You plug them in to the equation over here, and then all you have to write down is, if the terms are negative and positive, and then if the overall term is negative or positive, and then that tells you if they're local max or local mins. And because this one is going like this, as we can see, negative and then positive, it's a minimum. And then because this one is positive and then negative, it's a local maximum. And then B says, find all intervals over which g of x is increasing and decreasing. We know it's decreasing from -infinity to 0 to get there. And then we also know it's decreasing from x equals 13 to infinity. And then we know that it's increasing from 0 to 13. And then part C says find all inflection points. So the only inflection point that is missing is the point of inflection. The only critical point that is missing is the point of inflection. And you take the second derivative of g of x to find that inflection point, which is what I did incorrectly on the test. Not only in terms of location of the my solving it, but also my ability to solve it. I was confused. So g double prime of x equals -12 plus 78. You set that equal to 0, and then you have -12x equals -78. Divide the whole thing by 12, and you have x equals 6.5. And since this is a value reached by taking the second derivative of the function, you know it is a point of inflection. And you can see it go from, one type of concavity to the next, and you can see the point of inflection at x equals 6.5. Let's get into my additional example. So here we have the same learning target, and we just have a bit of a different one. So this states that r of t is 1 plus 80t cubed plus 5t to the fourth minus 2t to the fifth. And taking the first derivative, f prime of t, you take the derivative and then you set it equal to 0, and then you set all these points to 0, and then you have t equals 0, 6, and negative 4. Same thing, put them on the number line, use the values that are, less than, in between, and greater than these values, and then plug it into the equation to get negative, positive, positive, negative. And then this one, since it's going from negative to positive, we know it's a local min, and this one, since it's going from positive to negative, we know it's a local max. And then we take the second derivative of r of t, and that tells us the point of inflections, which are at t equals 0 and at t equals negative 3 plus or minus the square root of 20 over negative 4. And yeah, I don't know if I have another example. Oh, look, I do. So we have b, which is the whole part of it, the whole other part of it, and I basically just state everything that I was stating, and yeah, super awesome. I don't have much time to go over the other example, but I hope this suffices. Yeah.